we're going to talk a little bit about what is DevOps. Then we're going to have a look at the pyramid of strategy. Not know if that's known to you, but from that pyramid we will derive some values and vision and so subjects. Then we will look into SCM and IDE. I will tell a little bit about build platform, deployment unit tests, and a minimal viable implementation, and where Consultingwerk can actually help. So there were so many presentations about Docker, pipelines, Jenkins, and this will not be a technical presentation, so something different. Well, I work for Consultingwerk. You must have seen this slide 1,000 times today or in the past days. We are an independent IT organization focusing on open edge and related technology. We are located in Cologne, in Germany, in the UK, and in the Ukraine. And of course, we also have employees in Holland. We have customers in Europe, North America, Australia, South Africa, the Middle East, and more places. And we are vendor of tools consulting services and specialized in GUI for .NET, Angular, OO, software architecture, integration, and of course, application modernization. So, Smart Component Library. It's the framework for Open Edge. It's OERA, CCS, OO, ORM, DDD. And we support multiple interfaces, the desktop, the web, and the mobile with native script. And for the rest, well, you have seen this so much. So, who am I? Well, I wrote my first program somewhere between 6 and 7. I remember that I could earlier type some basic than writing my name. And I screwed up my secondary school by working in the meanwhile and writing software for customers. And when you write software, at some point you need to deploy that. The first versions went with diskettes and things like that. Professionally, I started with Progress in 1997. I did ABL development, I was a DevOps engineer, team lead DevOps, and currently I am product owner DevOps. And I spent my last 15 years on R&D and building development factories. So, what is DevOps? What do we do on a daily basis? Well, first of all, most important, we enable the developers to work with as high velocity as possible. So we provide the workspaces, the plugins, the scripts, the SCM, etc. We enable the software to be built and tested, so the pipelines, also helping QA. We enable releases to be delivered and to be deployed. Then we have a strong advising role on tool stack. So what tools will the developers use? How do we harmonize that? And in generally, we are just the oil between all of the teams working together. And last but not least, our least favorite job, incident management. So the pyramid of strategy. Who knows this thing? Okay. Well, I worked with this pyramid of strategy and I got comments from the architects. Really, do we have to really do this? This is something at CEO level. But I would say even if you are a Boy Scout and you sell cookies, then it's still a very good idea to look at the pyramid of strategy. So, top part, it's about the purpose. The middle part is about the strategy, and from that derived on the bottom is the execution. So first of all the way on the top, the question, why do we exist? What is our purpose in life? And for DevOps, that is facilitating the flow of value to our customers. Or in other words, continuously build, test, deploy, monitor reliable, traceable software changes. That is our purpose. So what values can we derive from that? Well, we like to work low risk. If you want to keep that incident management as low as possible, low risk. Communication. It's often even more important than doing something. I will get back to that. Cooperation, work with the sprint teams, make sure they are enabled, make sure you are on time, be a reliable partner. Stability, so well, we play with the production systems, we deploy them, so we have to think really hard about not crashing anything, because it's always very painful when that happens. It's always a production system, it always has great results. Right, so I lost that. Innovation, so when there are new tools to be decided or new ways of working, then DevOps should be involved to see that innovation, to see if it fits the strategy of the organization and if we can really work with it. I know many stories of managers who came with, we now have the greatest new tool or the greatest new language, and it just adds to the tool stack, it increases the complexity, and we do not really get happy from that. We want to be agile. We support sprint teams. So sprint teams are agile, they come up with a lot of ad hoc ideas, and we have to follow them and enable them. But at the same time, we also have to be realistic. So, like with the new languages, the new tools, there are people building castles in the clouds, and you sometimes have to put them back on Earth. Well, this is not for us right now. We cannot do this. This introduces risk, etc. And we must be stakeholder friendly. Reliable, cooperation. And the last value, which I think very high of, everything repeatable must be automated. So if you're gonna load that delta in the database for the 25th time, you are doing something wrong. So we go a step down in the pyramid, and we come with the vision. So, vision enables sprint teams to reach the maximum velocity, make everything plannable, also the ad hoc work, and have a fully automated development environment and fully automated build and testing. So from the vision, we come then down to the strategic objectives and clear and frequent communication. I put that on top. As said, communication is often much more important than doing something. When the build server is down and you do not communicate with all the developers, you get a storm over your favorite chat tool, a lot of time is wasted there. Well, if you just timely communicated, okay, there's something wrong, we are on the case, we expect a solution within 30 minutes, then everything calms down, people search temporarily for something else to do, and it goes much smoother. Well, if you want to have low risk, you go for standardized, predictable, and reusable code, deployment scripts, configuration, everything. Then redundancy and or fallback scenarios. So what happens if your deployment failed, your build server crashes, whatever? Do we have a fallback scenario? What can we do to not lose a lot of velocity from all the people involved? DevOps engineers should be proactive. So whenever you hear of an idea, a castle in the clouds, that is already the point where you have to make your ticket, put it in the backlog, and start analysis if it's possible to implement in the organization. Right, and oh my God, I put the word in. And avoid superfluous complexity. Right, so you have people that really make their software as complex as possible, and that means the maintainability is very low. You need specialists, and you don't want that. You really want anybody to be able to work. And, well, last but not least, security. This is not something about DevSecOps. Maybe next year I will do a presentation about that. But when you read in the principles of DevSecOps, then you will see that a lot of things come back in this presentation. So, execution. Start with optimizing all the processes and tools surrounding the developers. It are the most important customers or stakeholders in your development organization. If you have 40 developers doing nothing, that costs a lot of money. Be platform independent. People always want to switch with the newest hype, if it's nice or not, but for instance, now everybody is moving to Docker containers. Docker containers are mostly based on Linux, and that means that you just have to be platform independent and ready for it. And supply a stress-free environment. Put here a header of an article from Time. Decision making under stress, the brain remembers the rewards and forgets the punishments. Stressed people make mistakes. Recurring stress is toxic, can lead to a burnout, bad culture in the company, all over loss of velocity. It seems like a good idea at the time, but you can better take measures to prevent stress from happening. Right, when you have release stress, it means you're doing something wrong in your planning or in your process. Okay. So, enabling a DevOps team. First of all, I learned that by being a developer myself. Keep the DevOps engineers happy. Provide them with the hardware they need to do their work and the software to do their work properly. Compare it to a builder. You cannot let him build something with a broken hammer. Make sure he has the right tools for the job. Listen to your engineers, that they have expertise on certain matters. Maybe your expertise is there a bit less. You have to be able to trust on the expertise of your engineers. And make sure there is server capacity for build, testing. Sounds a little bit obvious, but a lot of times I come in organizations and, well, yeah, we need 3 test environments for that. We have some extra passaways there. We want to do something with load balancing. Okay, do you have the hardware, the VMs? So proactively make sure there is capacity hardware. Make your team members part of the roadmap and make them enthusiastic about it. Make sure that they also come with input. It should not be your idea, but it should be something the team can stand for. And, well, shield the team members from external pressure. That's, again, the stress factor. You don't want stress in the team. If the top management throws out all the shit over you because the release fails, you don't bring that in the team. And last but not least, the DevOps engineers are a lot like developers. So, well, who are the stakeholders? Well, on the first place, I put them on the first place, the end users of your product. can be your customers, can be in-house, of course. They can be represented by key users. They are an important stakeholder. Second one, the developers. If you do not support them, then the whole development stops. Then, well, nowadays we also have UI UX designers. They can also be a stakeholder. They also have certain demands and requirements on the whole process, and you need to help them. Of course, you have always the QA people. Think about automated testing, but just even the old-fashioned manual testing, there have to be environments set up with data that can be trusted in a certain state, etc. The Scrum Masters or the product owners from other teams are your stakeholders. Like I mentioned already 20 times, it's very important that the velocity of all the other teams stays as high as possible. You should not be the bottleneck there. So, well, release management is an important stakeholder. Then to a lesser extent, the product management, the project board, and the higher management. The last two you only really see when something goes really wrong. Product management, well, you need to talk to them sometimes because they can have those wild ideas and you have to calm down or really say support. I already mentioned keeping the stakeholders happy. That starts with communication. It should be clear, it should be proactive, it should be on the right time. And there is, in my opinion, no such thing as too much communication. There is a thing as too much information. People don't care about subjects where they are not involved in. So if you talk to your UI UX stakeholders, then you don't start talking about your pipelines and that kind of stuff. But you should communicate when certain things are ready. Make sure you can fulfill your promises there. I would say the communication here is the most important part of the job. Well, and with that, you want to identify cross-dependencies. So if a certain sprint team wants to deliver something with the newest Node.js version, then probably DevOps has to do something to update Node.js in the tool stack, see if it still works in the build environment, etc. And important, manage the expectations. Now, how can you keep the stakeholders happy and manage the expectations by prioritizing your tasks? So I have here a simple flow, a request for change. Is it a feature or a bug? Are the customers affected? Is there possible reputation damage? Can it go in the news, national, in the newspaper? Then you have a problem. Then it's highest priority, and yeah, there should be no discussion about processes, just fix the issue, and all the process stuff comes afterwards. Well then, for instance, when your developers are affected, are more than 5 affected, also highest priority. Are less people than 5 affected, high priority. So, and same if there is a bug, is there a workaround, it's low, is it requested for a hotfix in a new release, it's medium, and so to low. Now, content does not really matter of this schema. What you do with this flow is you show this to all your stakeholders. And can you agree on this? And then you can also, but I want this now. Yes, but you agree to this flow. And you see it does not benefit more than 5 people, so the priority will be medium. You agree to that. It's the clear communication that people are waiting for. Is this written in stone? No, not really. If you, for instance, have a little bit of a waterfall organization that does releases every so many months, and you have a QA team just before the release, then of course you give the QA team more priority than the other teams. You want to get the software out. So, and if you let all the stakeholders agree on this, you will get a more relaxed way of doing your job with less stress. So, now we go into a development factory, and we start with a developer, or really we start with a request for change. The change can be resolving a bug, a new feature, whatever. We need to change something. So the developer starts, and after he did something, he commits to the versioning system. Then we generate a sandbox somewhere in the pipeline. We do a build. After the build, well, we do the automated tests, so the unit tests and the API tests. We bundle artifacts, so we're getting somewhere near delivery, right? And we can do automated deployment tests, so we do an automated install somewhere. And could be that you still have a manual QA test just before the release. And then the software is finally released. Then it's installed. That can be on premises, that can be at a customer system, and it runs. And what makes it DevOps? When you have feedback from all those stages, preferably you even want to know the errors of the pathway which runs at the customer, and you want to know them before the customer does. So you need a feedback loop. You can do that with monitoring tools. You can write your own solution for that. And of course that starts quite early in the process. The first feedback you get is from the build, then the unit test, the deploy test, the release build, and the deployment and the running of the application. So, the DevOps tool stack. Yeah. It's a little bit of a bad side of DevOps engineers, some of them. They forget that our systems are production systems. So, when somebody crashes Bitbucket, nobody can work anymore. When somebody crashes the build server, nobody can work anymore. The traditional ops people are more aware of these kind of things. These are our primary production systems. We should protect them like any customer protects his primary production systems. My favorite moment. The next 5 minutes, I'm going to rant. And my first one is an old one. There is no cloud. You are just using somebody else's computer. I know the fashion is cloud. But who remembers GitLab? In 2017, they crashed, they failed to restore, and a lot of companies lost their sources. Emails disappearing from Google, vulnerabilities on the Azure cloud. I had another one. Oh yeah, Google Cloud ransomware, also very nice. You are just using somebody else's computer. That can be okay, but you should be aware of what you are doing. People think when you put it in the cloud, it's automatically backupped. That depends on which contract you have and what you are doing. So you see more and more a tendency for multi-cloud or hybrid cloud, where hybrid cloud is a solution where you have part inside the office and part in the cloud. The next one, my favorite subject, I hate Git. I work with it. I am somewhat of an expert in Git. But in my daily life, I run so often in this kind of situations. I have developers rebasing all day, having conflicts, having just overall shit with their Git repository. And I wonder why, because as a developer, you should be mainly focused on what your job is, developing, committing, and let it build and release it. So, first option, choose your SCM wisely. When you are doing something simple, a simple project, Git is great. When you are coming into a more complex environment where you have multiple repositories, different branching schemes and tags, it can easily end up in a lot of overhead. Multiple repos can, for instance, easily end up in a lot of scripting or unhappy developers or both. Well, already from the first slide, make sure it's replicated in-house or in the cloud. And you will not believe it, in 2021, almost 22, there are still customers who think that putting a file in a folder is source management. Don't have to explain. It's not. So that were my 5 minutes of rant. Well, a lot is happening in the area of the IDE. From Eclipse, we go more and more to web-based development. I was hoping that my presentation would be a bit earlier, but well, the presentation on Dockerized development has already taken place. And for DevOps, an IDE is only workable if it comes with the scripts, the plugins, to work with the SCM, the compilation, everything progress related. It's important. It's just not starting the thing and hoping that it works. You want a standardized environment for everybody, and it only works, well, usually there is a lot of work still to do to build your database, set up the right configuration, the right data, etc. So, the build platform architecture. I use the word platform here in the header because you also see more and more Azure build services. So it's not only physical hardware with Jenkins anymore. But still, build servers are special, and usually we need to convince the sysadmins, because those op people, they, yeah, but it should be redundant, and we should have a virus scanner, and it should be, yeah. We want an infinite number of cores, an infinite amount of processor speed, and unlimited I/O. That's really what we want. We want to build as fast as possible. We don't care if the workspaces are backupped. We only want to keep the artifacts, the test results, and the logging in the end. I worked at companies where we even built on a RAM drive, and where you switch the computer on, everything is gone. But we still had the artifacts on the end, the test results, and the logging. And this is really key. The key to enable developer feedback within 5 minutes. So when you commit something, within 5 minutes you should have feedback from your build server on the build quality, the test results, etc. When it's 10 minutes, you are working on your next task, and then you, later. So this should be as quick as possible. If it would be me, I would say 1 minute, but it's not really physically possible. And, well, protect the quality of the results, protect the build platform. Right, the worst build servers in this world are the ones where developers can log in and update a certain product, apply a certain patch, and suddenly your build crashes or has unpredictable behavior, and you are wondering what happened. So that build server should be a black box. You should keep your developers out. You should be sure about your Java version, your Java patch version, your OpenEdge version, the service pack, the patch, etc. And as said a few slides before, it's a production system, so don't play with it. When you crash your build server, developers cannot work. So you should have a test instance or a development instance of your build server, where you first test your updates before you deploy that to a productive system. We are even in the project where I'm currently working, putting the whole build server configuration in Git, then deploying that to a test system, checking it there, and then from Git deploy that to the production system. So black box it as much as possible. Preferably you are the only one who has access to that system. And well, obvious maybe, build and test with the exact same versions and platforms as on production or as your customer has. Simple example, Linux is case sensitive. When you build and compile on Windows, everything looks great. When you deploy it on Unix, you might have some real issues. So have a, what's the modern word? Have a node on Linux where you can build and test your software there. Use something to store your artifacts. Don't store them on the build server. It can be Artifactory, Nexus, or Azure. There are more options. Some customers even use a plain SFTP site, but store your artifacts somewhere, not on the build server. So deployment, right, yeah, I already said be platform independent, make sure it works everywhere. Classical Windows, Linux, physical, virtual, cloud, containerized in Docker. But the most important one, please do not use deltas. I still see some people coming with a delta DF that you have to apply from version 2 to version 16 to get something up and running. Use PCT in your deployment, build an empty database, load your DF in there, the full DF, diff that with the productive system, and make sure that your productive system loads that DF. There is no need for a delta. And progress has become less strict in CRCs, so it's easy to do. I never have problems with that. Unit tests, yeah, I do not have to convince a lot of people anymore. It's not really a DevOps thing. However, I also wrote unit tests for the DevOps scripts, but this is more progress related. Create the unit tests. When you do a new project, start from that, from the beginning, because the advantages outweigh the effort infinitely. You can repeat those unit tests. You can execute them on your build server with every commit. For instance, our smart component library currently has like 18,000 unit tests which are executed on every commit. Does that take long? No, we do them all in parallel on a quite heavy server, and we still reach feedback within 5 minutes. And well, like with Smart Unit, ABL Unit, but your unit test must, of course, also be executable in your IDE. So, all sounds pretty complex, but what is the minimal viable implementation of a DevOps person or team, small team? Well, you need a DevOps engineer, hopefully somebody who is interested, so not just the victim, you are the one that needs to deploy it. I come in organizations where they have such a victim. Sometimes it works, sometimes the results are less than okay. So, if you want to enable your developers, you need the standardized development environment with your scripts, and you need an SCM, and as I stretched before, with a backup. And you need a controlled build environment with unit tests and a deployment solution. Right, oh yeah. Things that look so great to developers. We now have NPM. It automatically downloads all dependencies. We now have Cradle. It automatically downloads all dependencies. As a DevOps engineer, I am really unhappy with that. I want to control it. And we have seen 2 weeks ago that some dependencies were hijacked and infected with viruses and ransomware, and then you can have serious problems. So countermeasures, npm audit command, or use a local repository. So, well, Consultingwerk can help, and for the DevOps architecture, advice and consultancy, we can do DevOps engineering, development, and set up a DevOps team. Wow, that's the most timely presentation I ever held. Any questions? Cool. Then, thank you very much, and have a nice remainder of the evening.